John Durham Peters is Maria Rosa Menachal Professor of English and of Film and Media Studies at Yale. Peters teaches and writes on media history and theory. He's the author of Speaking into the Air, A History of the Idea of Communication, Courting the Abyss, Free Speech and the Liberal Tradition, recently The Marvelous Clouds, Toward a Philosophy of Elemental Media, and even more recently, Promiscuous Knowledge, Information, Image, and Other Truth Games in History. And that last one was written with the late Kenneth Camille, and all published by the University of Chicago Press. And he's currently working on a media history of weather. John will be presenting M87 today, a talk called M87, Can You Take a Picture of a Black Hole?
Thank you so much. Thank you for the invitation to be here. Thank you for organizing this wonderful event. My talk is very much a footnote to thesis number 5 by Ernst and Schröter. And this thesis 5 says that future media serve as generatively imaginative or imaginary objects that bind together the diverse interests of multiple actors. I'm interested in the M87 black hole because our very knowledge of it is the product of perhaps the most advanced media network in history, and because the physics of black holes, if anybody understands them at all, offer strange insights about past, present, and future. The ambiguities in the Event Horizon Telescope black hole picture, released to justify a claim in April 2019, intensify questions both about media and their ontological signature. This is a supermassive black hole with a mass of about 6.5 billion times that of our sun, which sits at the center of the Messier 87 galaxy, 55 million light years away. It is not clear if photograph or even picture is the right word. What was widely hailed as a picture is better understood as a data file, a composite of observations, a compilation. It was a capture as much as a picture array of space-time as much as a visualization. The data sets were so big, the team had to physically ship half a ton's worth of hard drives to supercomputer centers rather than send the data online. When the files are big enough, old-fashioned transportation beats the internet. Just what is this strange thing we are looking at? The telescope that saw the black hole was not a single telescope. It was a network of 8 radio observatories at 6 different stations around the Earth. In Arizona, Chile, 2, Hawaii, 2, Mexico, Spain, and the South Pole. It was more or less a virtual telescope with an Earth-sized aperture. The black hole image is thus also a feat of political and social coordination, the culmination of over a decade of work. It is a classic example of an infrastructure of knowledge in Paul Edwards' sense, requiring the mixing of different systems and standards. The black hole, despite the amount of light it spurts out along its infinitesimally thin event horizon, i.e. the edge between the iris and the pupil, you can see that, is very difficult to see because it is so far away. It is, as one of the members of the team put it, smaller than the edge of a dime in Los Angeles as seen from Boston. When the Earth rolled away every day and stopped facing the part of the sky with the black hole in it, another pair of telescopes would watch, leaving the celestial object, if object is even the right word for something that devours matter, always observed. The network kept an ear on the spot at all times. This is certainly no ordinary image by any standard. This is a member of the team put it, this is a picture you would have seen if you had eyes as big as the Earth and were observing in radio. Here Earth turns into eyes, and eyes turn into ears, and monstrously vast data points turn into enhanced, sensuous pixels of color. Here the Earth is not a single image to be seen, as in the famous blue marble image I'm showing from 1972, but it's actually doing the seeing. Here, Earth is much more projector than image. It is not just a point. Its circumference is the precise aperture that enables it to see light, or rather shadow, that is 55 million years old, or 55 million light years away, which are probably, if the universe is still holding, the same thing. The Event Horizon Telescope, those three words together sound a bit like a title from Friedrich Kittler, operated through pooled simultaneous observations. As of 2018, each station recorded at 64 gigabytes per second, an increase in speed from 4 gigabytes per second a decade earlier, an acceleration that parallels the more general advance in the computer processing industry known as Moore's Law. Even 10 years ago, the black hole would have been extremely difficult to observe. The full network used 128 hard drives running in parallel, each one having a storage capacity of 6 to 10 terabytes. A full observing campaign involving all 8 observatories would need about 15 petabytes of data storage. Just for comparison, 15 petabytes would provide enough space for 18 million hours of video. That is over 2 millennia of TV programming played 24/7. The network is the result of a lot of fancy electrical engineering. It is one of the most advanced systems of data processing on Earth. Just as the brain processes differences of action potentials internal to the brain in order to calculate the timing of external events, as in hearing, so the calibration of minute units of time on Earth was essential for observation of a so-called object 55 million light years away. Time coordination between the observatories was done by atomic clocks using hydrogen microwave lasers linked to the global positioning system. Here it gets a little bit dense and also, so don't hold me to the engineering details. The synthesis of signals employed, quote, an a priori Earth geometry and clock delay model to align the signals from each telescope to a common time reference, close quote. The slight discrepancies of the now on Earth matter profoundly and are themselves primary data when you are tracking an object 55 million light years away. Sampler clock phase mismatches were central to the analysis and the calibration of the data. They needed to do highly precise time tagging. Temporal alignment between distant observatories typically occurred within tens of nanoseconds. That's obviously calculation at computer speeds. The distance between the dishes allowed for far more sensitive resolutions thanks to very long baseline interferometry. It is almost like high frequency trading in the stock market. That is, the use of ultrafine slivers of time to create spaces of knowledge and value. The vision, or at least perception, of the black hole presupposes mastery of the microtemporal scale. As always, perception depends on time-critical processes. The calibration of transit times on Earth revealed the behavior of light in the cosmos, or the absence of light, rather, since it's a black hole. The telegraph, in other words, this networked, space-transcending, fine intervals of time-producing medium, remains at the heart of cosmic observation, a point famously made by Peter Gallison about Einstein's clocks. Gallison, as you might know, was a member of the Event Horizon Telescope team. The image the team produced could well be called the theoretical composite, a term Gallison developed with Lorraine Daston to talk about scientific images that combine the expertise of the learned eye with the mechanical objectivity of the camera, or some kind of camera. Could be an X-ray, radiograph, for example. And in appearance, the image is a luminous asymmetric ring, rather like an eyeball, with a black round center pupil surrounded by a fiery iris that is orange-brown to the north and yellow to white-hot in the south, with outer edges that fray into the background indefinitely like the sides of a rainbow. You can't quite see where they leave off. or more technically, the image is a nearly circular ring with dark center and azimuthally varying intensity. I don't know what that means exactly. That's a quote. It is reminiscent of coronagraph images of the sun, in which a black disk covers the sun in order to make the corona visible, except that the black disk is natural, the black hole itself. The brightness is a measure of temperature. So they're choosing to try to show 9 to the 10th Kelvin. The dark center is known as the shadow. The line between the pupil and the iris is the famous event horizon, the line at which photons get sucked into the space and time-defying mass. This visual depiction of negation, of skyography, of shadow writing has a long history. Pliny, as we've seen already talked about, the origin of drawing being the shadow of a human being with lines drawn around it. X-rays are shadow writing. Sundials are shadow writing. But it's interesting that when we look at the history of sky images, in which I include the black hole image, that negation and erasure have been the hallmark. Astute early observers of the daguerreotype noted both its thick saturation of detail and its tendency to erase. Not only was the camera a robotic scrivener of appearances, it was an oblivionator, to use Herman Melville's word, of what is. The sky, for instance. In Daguerre's famous image from 1838, often regarded as one of the first photos, not only have all the moving objects disappeared, leaving a very busy Paris boulevard wiped clean of people and traffic, save the famous man getting his boots blackened, but the sky is glowing weirdly, uncannily bright, as if a nuclear bomb has gone off. And taking a well-focused and crisp picture of the Earth, the one in which all movement has been oblivionated, the sky was inevitably overexposed. Call this the nuclear sky. Sky and ground could not coexist in the medium's very limited dynamic range. It was not only clouds that were moving, but the sky itself so full of light, especially blue light, which the chemical mix of early daguerreotypy was oversensitive. In most outdoor photographs of the 19th century, the sky is little more than a blank brightness. To get both, you had to resort to combination printing. This is a famous combination print, which Charles Baudelaire made famous by writing about. This image by Caillebotte, Caillebotte is basically, you can see how he's taking on board photography and painting. The way that the man on the right is cropped by the camera. But I'm interested also in the way that the sky looks like a photograph sky, a sky which has been oblivionated and wiped out. Overexposed skies are still a problem. Recently, 2 years ago, I took a picture of the Norwegian heath on the island of Frøya with my iPhone without turning on the fancy high dynamic range tool. The bright sky atop the small hill on the right looks completely white against the wet purple, green, and silver tufts on the ground. You've also noticed this in photos of the Martian sky recently, which show a washed out reddish brown, though it can turn blue around the setting sun. So does photography capture light or does it melt down light? This is the problem which the black hole so-called image raises for us in an acute way. Because the image reality boundary melts down along the event horizon subring. The telescope and the black hole are both competing for photons. The black hole is itself a kind of camera, or better, an archive of past, present, and future. Indeed, making a picture of a black hole is a funny undertaking, since a black hole is just as much a light eater as a camera is. They are twin distant kin. In fact, of course, the effort was not to take a picture of the black hole, but to detect the black hole's shadow. It's precisely where photon capture at the event horizon happens that the black hole becomes visible as a negative. It would really take a long time to figure out all the layers here. The black hole image is actually kind of like an anti-photograph, like many photographs are. In these and similar pictures, Bilderverbot, or a ban on images or image making, is inherent in the image itself. These are images of what cannot be made into an image. This is a glimpse of impossible, as a popular essay put it. One of the team's letters asserts, quote, general relativity predicts that embedded within this image lies a thin photon ring, which is composed of an infinite sequence of self-similar subrings that are indexed by the number of photon orbits around the black hole, close quote. What should we do with this casually ontologizing language? Embedded within this image lies a thin photon ring. Which image? Is the photon ring 55 million years away embedded in the image on my screen, on your screen? Are the photons preserved in those pixels? Or is the subring itself the image? Even more weirdly, consider this line from one of their letters or articles. Quote, a telescope with perfect resolution directed at a black hole observes an infinite number of nested images of the universe. Each image is thus an increasingly delayed and demagnified snapshot of the universe as seen from the black hole. We see a self-similar sequence of relativistic images. Now, I certainly don't understand what this means, but I certainly like it. This sounds like the Aleph as imagined by Jorge Luis Borges, who of course knew that the Aleph was both the mathematical and Kabbalistic term for infinity. Somehow the black hole is akin to the frames of a movie. My concluding paragraph. Black holes mess with the mind if you want to think about the future, as we do today and tomorrow. As Carlo Rovelli, the theoretical physicist, notes, quote, the mass of the black hole slows time to such a degree that at its border, called the horizon, time stands still. To exit from a black hole, you would need to move toward the present rather than toward the future, close quote. That's the hard thing, moving toward the present. Maybe that's confusing enough. Black holes, he says, close off a region in space in the future from everything that surrounds it. I don't get this. But anyway, Einstein's discovery that there is no now in the universe extends to the atrociously weird horizon of the black hole in which there is no present. So maybe our task as critics and scholars of media and the very strange, dangerous, exciting, odd universe in which they bring us is to move to the present. Maybe our task is to sort out the noise on Earth in order to see far into the future or far into the past. Maybe negation and shadow are the royal road to knowledge about media in their most radical form. Thank you for listening.